Right, okay. Can we all see me? Can you hear me?
Yes.
Right, okay. Well, let's fire away then. Okay, this talk really is one that anyone that went on the Dipterists Forum field meeting this summer will have already heard, so you can go off and have your cup of tea early. For the rest of you, then I'm going to try to give you an idea as to why we've seen what appear to be very substantial declines in many insect groups, and especially in some Diptera. The presentation technically is me, but because Stuart has put in quite a lot of work on some aspects of the analysis, it's me and Stuart. And you'll see the same thing with the paper that we've just put in British Wildlife. So let's move on. I'm going to use hoverflies as an analog because that's the data set we play with. It's not to say that it's the only data set that could be used to highlight some of the issues, but one of the nice things about hoverflies is that they utilize a very wide range of habitats, and as such they may actually provide more pointers than some groups of insects. As you can see from this particular slide, we're looking at declines in hoverflies. These have been predicted or established using the package Frescallo, which was written by Mark Hill and published in around about 2012. Stuart actually wrote an R package for it, so if anyone wants to play with Frescallo, they can do so. That's R Frescallo. The story is quite an interesting one. I mean, in this particular one, we're showing changes between 1980 and 2012. And as you can see, we see a decline of something in the order of 41%. Now, that's a bit variable because it depends on how you interpret the data set. I won't go into that at this stage, but there are some complications. Since that particular presentation was put together, Stuart's done another analysis, and we now come out at something like 55% decline. So it's pretty serious, and the steepness of the decline can be picked up from the graph on the right-hand side, which not only produces the rate of decline, but a 95% confidence limit. So, I mean, what we are saying there is that there are quite broad spread of confidence in what the decline is, but there's absolutely no doubt there is a sharp and very considerable decline. But those declines are not uniform, and I think this is probably one of the things that doesn't come out very well in analyses that we see published. You see national declines, you see predictions of declines and so on, but if you start to break it down into regions, you see that there's a very substantial difference between most of the British Isles and the southeast. And that gives me some reasons to suspect that there may be something rather unusual going on. There are several possibilities. The normal view, or the received wisdom, is that the main reasons for insect decline are agricultural intensification and pesticide use. Now, there have been papers in which it has been argued that the correlation is pretty good for agricultural intensification and pesticide use, and that the correlation between climate change and insect status is one of benefit, where insects are actually expanding their range rather than contracting their range. So when we start adding climate change into the mix, we must recognize that there are conflicting messages coming out of the data. Agricultural intensification and pesticides, there's quite a nice paper by Manciniar and et al. Published in 2020. When I looked at the map of that, it struck me that there were some considerable similarities in it to other environmental factors. So although it might be that they picked up a strong correlation with pesticide usage, I don't think that's the whole story. There is an alternative theory, and Professor John Wines in America came up with a series of ideas, 2 papers that have been published that I think are pretty compelling. They resonate very well with some of the observations that I've seen in the field. And I do stress here that a lot of what we're talking about is trying to match up responses to field experience and not simply to running a model or looking at a data set. It's understanding how the animals actually behave in the field. So I think there are a number of other factors that we might take into account. I'm not the only one. Stuart thinks the same, and there will be other people as well. So the first thing that a lot of people talk about is unusually cold spells. And a lot of people say, well, what about the beast from the east? Well, the beast from the east was not even a beast. It was a mere whimper from the east, if you compare it to the winter of 1963, which I can remember because my family home froze up so much that we had no heating for 6 weeks. That's one end of the scale, winter freezes. The other one that's probably more interesting is cold snaps, and we saw that this spring. Now, I won't go into that in too much detail, but I think there may actually be a developing picture of a new climate in which you get these cold snaps. Heat waves, well, everyone that's over about 50 can certainly remember the 1976 heat wave, and it was pretty profound. But there have been a lot more, and some of the recent ones have been almost as profound. The one difference that we do have between the 76 drought and more recent ones is that 1976 or 76 heat wave was that more recent ones were not preceded by a drought. And in that respect, 1976 remains a little bit unusual because there were the better part of 18 months of drought with a heat wave towards the end of it. Nevertheless, we had drought in 1976. We have had a number of quite profound droughts since then. I lived in Yorkshire in the mid-1990s, and I remember the procession of water tankers between the west of England or the northwest of England and Yorkshire, trying to keep us with enough water to shower and bathe in, whereas actually all we needed was drinking water. And then floods. Well, floods do some quite interesting things as well. The most profound one recently, I suppose, was that of 2013-14, but we've also seen some pretty extreme weather this year. So a whole sequence of extreme weather, all of which could impact on invertebrates. The one that I'm really interested in is heat waves. Oh, excuse me. And this map, it's one of many that have been produced, but it gives you an idea of heat wave pressure across England. Now, it's just worth bearing in mind that although there are differences between this map and the pesticide map, there are also some quite strong parallels. And I reckon that's telling us something quite important. Now, trying to understand extreme weather is extremely difficult. There are no easy metrics. That can be presented in all sorts of ways, but for this purpose, Stuart plotted the number of days of temperature over 27 degrees between 1880 or the 1870 actually and 2020. And I think the story is pretty compelling. It bounces around an awful lot, but as you can see, the numbers of hot days are rising and do seem to have been rising particularly quickly post 1960. Now that really starts to correlate to some extent with what we see in insect decline, which has been a period of decline from the 1980s and an increasingly steep decline from around about the mid-2000s, perhaps a little bit beyond that. So we can come up with a bit of a conceptual model. And I remember from work, people said, oh, we don't want any models. Well, all models are based on conceptual models. And I'm a great believer in conceptualizing circumstances so that you can build an idea of what's going on. So my conceptual model is based on a number of factors. The first one is that extreme events lead to localized extinctions. Now, John Wines has brought that up. It's certainly not mine, but nevertheless, it is something that we need to think about. And we need to think about how those extinctions happen. Shortening of adult lives, reduction in fecundity, or the death of juvenile stages. Now, all of those can have some effect and reduce populations. Extreme cold winters have been shown to knock out populations on the edge of range. So we can certainly say that edge of range species are vulnerable in cold circumstances. And we saw this with Volucella zonaria in the 1960s. But those species, conversely, are the ones that are likely to respond very positively to warmer temperatures. And as we've seen in the last 20 years or so, species such as Volucella zonaria have gone stupid and gone right the way through the country. They're now up in Scotland. Stuart predicted they'd be in Scotland in 2004. He was only 2 years out. It got to Glasgow in 2018. He thought 2020. So that was pretty good. Extreme flooding, again, leads to localized drownings of faunas. So again, we see localized extirpations. Now, the important thing there is that if you start sampling seasonally flooded woodlands, they're often miserable. You go in, you sweep like mad, you end up with large numbers of chironomids and fairly fast breeding species. You don't see a great deal of interesting species. So we can say that all three of those factors may have an impact. Heat waves, well, there's developing evidence of sharp declines in detected insect activity. Now, the problem we've got is that when you look at these declines, we can't say with absolute certainty that the decline is no insects. It may be that the insects are there and they haven't been detected, or it may be that those of us that go out to detect them don't like going out in that weather and therefore don't detect them. I'm still persuaded that actually they're not there. And one of the reasons that one might be convinced by that is that when we have these very hot periods, we see a spike in human deaths as well. And then there's the most obvious thing on the ground. If you have a drought, water bodies dry up, and particularly habitats that are based on clay. I mean, clay can turn into something like concrete. Now, if you're a ground-dwelling insect or an insect larva in such ground, you're not going to do very well. And if the spring that you live in or the seepage line that you live in disappears, your chances are pretty small. So these normally wet places are going to be pretty rapidly affected by drought. And so we must expect that populations are being eliminated. And the big question is, can they recover? Now, if suitable conditions reoccur, then maybe recolonization is possible. But a lot of the things that we're looking at are highly specialized. The habitats that they live in are generally quite small. You know, we're not talking about acres and acres and acres. We may well be talking about a few dozens of meters. And fragmentation of habitat obviously makes this increasingly difficult. So in that respect, a combination of local extinction together with a wider loss of habitat would combine. So that would support some of the arguments that it's habitat loss that's the problem. However, these species are highly specialist and in the wider countryside probably don't occur as widely as people think they might. There is some evidence of declines that may be reversed by changing conditions. Certainly that's evident from upland cranefly populations where re-wetting of blanket bogs and the edges of the uplands has been shown to quite rapidly reverse losses, but that's dependent hugely upon there being a residue of the species concerned. And with that, we also see improvements in bird breeding success. So that will come back in a minute. And then, of course, the real issue is, if these events happen, is there enough time for a recovery in the population? And obviously, the more frequent the event, the less chance there is of recovery. And we're looking at something akin to death by 1,000 cuts. Stuart and I have titled that death by 100 droughts, but there are a number of other factors too. So where are we moving? Well, one of the reasons to be interested in flies is that a lot of flies are strongly wetland associate, or they are particularly associated with high humidity. So they're going to be very, very vulnerable to loss to heat waves and drought. What we don't have at the moment is a full understanding of the thermal and humidity gradients that individual species are associated with. And I think that's going to be quite an interesting area for future research. Dry habitat species highly at risk from flooding. And certainly if you look at places like the Somerset levels, those species that were just above the wet margins would have been particularly vulnerable. And then montane species, well, they have a double whammy. Firstly, they've got a risk of heat and drought when we do have droughts. And then we also have the problem of shorter winters, and indeed not just shorter winters, less snowfall, therefore less water in the spring, therefore more risk of drought within upland wetland systems that are pretty reliant on a continual supply of water. They're usually on quite hard rocks. There's not much of a residual water table. So we've got a combination of factors there of weather, but also of the geography, and in particularly the lithology of the area. And if there's insect decline, well, it's a no-brainer, isn't it? If there aren't any insects about, what are the birds going to eat? Now, a lot of birds may feed on seeds, for example, but they'll feed their young on insects. So an awful lot of seed eaters that we consider to be farmland birds may actually be suffering not from a loss of seed, but actually a loss of insects in the spring to feed their young. And then the other side of it, species like hirundines and so on, that are highly associated with aerial plankton, and perhaps aerial plankton that are driven by things like chironomids. If wet habitats dry up, there isn't any insect biomass. Therefore, there's less food. Therefore, they have less success in breeding. And when you bear in mind things like swallows may have 2 or 3 broods in a season, if there's no food, you're not getting the 2 or 3 broods, and therefore the numbers of new animals recruited to the population must decline, and decline quite quickly. So I'll give you that as food for thought. I'm doing a bit of work with BTO at the moment to try and take this a little bit further forward. And I hope, with any luck, it might stimulate a lot more thinking and perhaps a little bit more research. Thank you for listening.
Thanks very much, Roger. That was very interesting. We have a question in the chat from Mike Ashworth, and he says, Roger, could increased temperatures cause an increase in the populations of pest species, causing an increase in pesticide use and therefore declines in all species?
Possibly. There is some evidence of aphid populations rising, and it is possible that you'd end up with more pesticide use. But the one issue that I would take there is one's still trying to put the blame on pesticides when the vast amount of damage done to the countryside by both the pesticide world and the development world has already happened. If you look at the way the countryside has changed over the last 100 years, my mother described pre and just post-war the Derbyshire Dales being absolutely a sea of orchids. Going back there now, you've got a few tiny fragments. The same thing holds with if you go to Lincolnshire. You can put as much pesticide on the fields of Lincolnshire as you like, but the biggest issue there is there aren't any insects anyway. They've already gone. If you're lucky, there's a few in the drains, but there isn't much around. It's one of the least biodiverse areas in the country. So I think when you start looking at what we're talking about of declines in a broad spectrum of specialist species, you're not getting those specialist species in that agricultural area. The specialist species are, for example, those that may be in, for example, the southern woodland belt, southern forest belt. And Stuart and I are picking up innumerable declines or disappearances of species that you just would not associate with the impact of pesticides. Even on my local site, I'm seeing things disappear. Now that site's buffered from pesticides by about 10 miles of urbanization. Not any more urbanized, it's perfectly buffered, but they're going or disappeared.
Okay, a couple more questions for you, Roger. This is from John and Barbara Ismay. Do you think the building pressure in the southeast also has an impact?
Sorry, do I think the?
Well, just the sheer amount of building that go, the huge conurbation that is the southeast of England.
No, I don't. I think that is a small impact, and it goes back to my last answer. The species that we're seeing declining are species that are very often associated with habitats that haven't been built on. For example, I'll use my local site. It's the better part of 300 hectares of open ground, a mixture of secondary woodland and grassland and a few wetlands. In the 1980s, I used to see Leucozona leucorum quite frequently. I haven't got proper data. This is a classic example of you really ought to record absolutely everything all the time, because when you go back, you need those data and they're not there. However, Leucozona leucorum was perfectly present in the 1980s. I last saw it on that site in 2002. Over the last 4 years, I've been recording that site on a daily basis and haven't seen it. So it was a common species, it's disappeared. I don't believe for the life of me that that would have gone because someone's built on a local playing field. It just doesn't work. And there are many, many more, as I say, in the forest belt of southern England that used to be there. They're dead obvious species. They're ones that today's recorders record very easily, something like Leucozona glaucia, dead easy to photograph, obvious thing, and lots of people recording in the south of England. It's virtually disappeared from the forest belt. You can't put that down to development.
Yeah, good point. Okay, some more questions. From Gabriel Levy, are there any data on which life stage, brackets egg, larvae, pupa, imago, are the most sensitive to heat waves?
This is an area where we need a lot more work. There will be some data, but it's by analogy rather than by detailed research. The most obvious one is the one I quoted, which is cranefly populations in upland wetlands. By re-wetting those wetlands, cranefly numbers have increased. Therefore, by extrapolation, we must assume that in dry conditions, cranefly larvae suffer pretty badly. That's a no-brainer. They're wetland craneflies. If it gets dry, they're not there. If it gets wet again, small pockets of population do recover. and recover quite quickly. The thing that we need to bear in mind is that a lot of these animals breed in vast numbers, and so it may only take 2 or 3 years to see a full recovery. And what we really see is a very rapid recovery by species that are multi-brooded. So, for example, we're not seeing declines in things like Epicervus boltiatus. What we do see is year-to-year fluctuations in their abundance, but we don't see the declines that you would see, for example, with something like Leucozona glaucia, which, to all intents and purposes, has disappeared from southeast England. And there are 4 or 5 other species that I think either are at that stage or very close to it.
Okay, another question, this time from Rob Davis. Insects as a food source for people, with there being an increasing interest in this, can commercial interests help biodiversity? Exploratory question on thoughts on micro livestock. Hope this is not a silly question. Of course not, Rob.
Well, let's separate out what we're talking about. Commercial production of insect biomass is very much associated with species that are quite generalist and fairly easy to provide the environmental circumstances they need to breed up. That may well mean that you could breed up large numbers of chironomids and release them. It would be a very labor-intensive process, but it might help a localized hirundine population. I don't think it'll increase biodiversity. I think it'll just simply be a distraction. My instincts are that all of that sort of effort is going to be very expensive and will take our minds away from resolving the bigger issue, which for my mind is we need to think much more about how water particularly is conserved. We need groundwater plans. We need to understand where the greatest risks are to biodiversity. And that's not just your traditional wetlands, it's seepage zones. People just do not think of it. And I think we need to see a very different attitude in, for example, we see what call themselves landscape ecologists, and they spend a lot of time mapping things that, quite frankly, are irrelevant. You know, oh yeah, we'll have a woodland here and a hedgerow here and the bats will fly down that. Well, where's the seepage line for specialist insects? You know, all those sorts of things. So yes, you might have a few more bats and you might have a few more badgers, but you're not going to address the bigger biodiversity issue until you actually make sure that there isn't any pumping that's removing the water that maintains that seepage line for life, or that maintains the winterbournes, for example, on chalk. So those are the sorts of issues that we've got to put our mind to.
Yes, I think any ecosystem that you want to conserve, you've got to think about the insects, because they're the producers. They're at the bottom of the food chain. So
that's right.
Okay, more from the chat. Brian Nelson, some very interesting thoughts by Roger. I think the impact of climate change is a final stage of what has been a loss of habitats. That is what drives fragmentation and therefore the loss of species. In Europe, are these species declining? After all, the GB climate is not extreme compared to France, Spain, other hotter summers and colder winters. So do you know what's happening to some of these hoverflies that you've talked about on the continent, where they're going to be having more extreme weather?
Well, obviously, there's quite a long way to go before we have a view across Europe. I mean, what Stuart and I are talking about is fairly new. However, I have had quite a lot of communication with friends in Holland and Belgium, and the arguments that I've put forward about the Leucozona species have been borne out. The Dutch particularly say, yes, they've gone from Holland. And what they've also warned is that species that we still get in southeast England are disappearing more rapidly in Holland. So I think we must start from the principle that we've possibly been buffered. The biggest issue is we don't have data. The UK is very lucky because we have some of the most active recording schemes, and they've been active for 40 plus years. Most of Europe doesn't have those. It has data sets that may well be developed by a small number of specialists, but it doesn't have the depth of data that the UK has. So trying to marry what's going on with Europe with what's going on here is extremely difficult. That is part of the research issue that we need to think about. But again, I come back to the point that although fragmentation of habitat is something that has been responsible for declines in the past decades, what we're now looking at is a fundamental change in the hydrology and humidity gradients of remaining habitat. So it doesn't really matter now what else is going on. It's the fact that we've already got this problem for those sites, and they are now so much more isolated that recovery is just not possible.
Interesting. Okay, Roger, on the timetable,
Yeah.
the coffee break was scheduled to start at 11:25. So we've rolled past that.
Oh dear.
Will isn't due to start until 5 to 12. So I think if people need a break, you're welcome to do so. Roger, are you happy to answer some more questions? Are you willing to carry on?
Yeah, I mean, I'm quite happy to. You know, people can throw things at me. I mean, I'm here to talk.
Okay. Well, there's a few more in the chat, so I'm going to carry on going through the questions. And I suggest that anyone who'd like to take a break, now is your opportunity, and return at 5 to 12 for Will Hawke's talk on insect migration. So with that, back to the questions. Okay, next question, Roger. Now, where was I?
Yeah, I'm just trying to work out now how to, I think I'll turn off show screen. There we are. Gets rid of some of the, right, that's better. So I can talk to you.
James is asking about, what about urban pesticide use? How much impact does this have? So what, people using stuff in their gardens? I think that might be something that's has changed in recent decades. I think people used to be much more willing to use a lot of pesticides in their gardens, and they're now, people like the RHS are trying to persuade people not to do that to the same extent. So that might be quite a difficult thing to unpick. What do you think, Roger?
I think you have to look at everything in proportion. Yes, some people will use pesticides, and yes, there is a lobby that's very anti-pesticide. Now, I'm not necessarily pro-pesticide, I'm not. I think we can minimize that. But I think it's very easy to throw bricks at a traditional problem. I would be more inclined in the urban environment to blame everyone that worships their car, turns their front garden into a car park, and turns their back garden into decking. I think that's far, far more likely to be causing problems. So as far as I'm concerned, I'd get out the Kango, I'd dig up all those front gardens, and I'd turn them into nice thistle patches.
Okay, you heard it here. Those are your instructions for next weekend, I think, yeah?
Yeah, I'll probably get slaughtered for
that. Okay, from Rob Davis. Would there be, or would there only be interest in some particular species? I wonder if there's an opportunity for philanthropy by commercial enterprise to help market their product in this area. We help diversity by insect welfare while providing meat alternatives. Okay, so this is a follow-on from Rob's earlier comment about commercial growing of insects for food. I think what you said earlier about the species that get grown commercially in these factories, I guess, they tend to be generous, don't they? Things that are easy to culture don't have very stringent requirements for their growth environment or their food and nutrition. And so they're things that cope better with stressed environments anyway, aren't they? So they're not necessarily the species that we're going to lose as these changes happen. Would you agree with that, Roger?
I think there's a common thread to this. It's much the same as people saying, well, we really must return sea eagles to North Norfolk or to the Isle of Wight. That gives everyone the idea that you can solve your biodiversity problem by the influx of a few little things. We've got a tweak. Now we've got sea eagles, everything's all right. Now we've got 200 extra episurface Boltiatus released in every garden, everything's all right. Frankly, that's not. If you're going to cherry pick the species that you preserve out of Britain's Diptera, well, we've got 7,100 species. If you choose 10 species that you can breed up, you're losing 7,090 species potentially. You won't lose that many, but you know, seeing a decline of something like 50% over 40 years. Now that's a 50% decline in the T factor. It's not 50% decline in biomass. The Germans have found 75% decline. We're just not going to deal with this by some sort of commercial, let's breed up some insects. We've got to change the way that we manage the landscape, and we've got to change people's perceptions of what they can have in terms of facilities. For example, whilst it might not be very nice, I think we've got to start saying to people, you only need to take a shower once a week or twice a week, not 3 times a day because you feel sweaty. You know, I mean, we might keep social distancing or work a lot better that way.
Okay, so final comments from Rob. I think he's saying these micro livestock places, it would be part of their deal that they would have to allocate part of their facility to sensitive endangered species, and they would have to do some philanthropy on the side if they were a going concern. So
I think there may be a case for some of that, but I think you've got to then look at, it comes back to what I said earlier about lithology. If you look at the landscape of Britain, there are certain places and certain parts of our geography that are extremely biodiverse. On balance, they tend to be places that are on the calcareous side, and so you're looking mainly at limestones or lime-rich or basic-rich soils. They tend to be deeper soils. So when you start looking at biodiversity across Britain, it is naturally less biodiverse on harder rocks, and it is particularly non-biodiverse when you get onto the coal measures. So for example, if you go to Ayrshire, it's almost an insect-free zone, not because Ayrshire's heavily agricultural, although it is. It's because the coal measures are just incredibly poor soils. And you see that elsewhere on the coal measures. The same thing holds in the uplands. As soon as you get onto highly metamorphic systems, they are much, much less biodiverse. If you get onto some of the serpentines, where you've got a lot more base influences, all of a sudden you have an explosion, radiation of interesting plants, and you see insects that you just wouldn't see anywhere else in that area. And that's the geology, that's not the climate. So we have to start thinking much, much more richly about the underlying factors behind insect distribution. And we just don't see people looking at it that way.
Yes. Okay. So comments from Rob. Thanks for reading these out. Great answer on biodiversity. I agree. Thank you.
Good.
A convert. Okay, question from John Showers. Is there an effect detected of climate events on saproxylic species?
Oh, now that's an interesting one, John. I think, but I can't completely prove, that there is something of a radiation of saproxylic species as a result of warmer summers. We're seeing that with things like Calycera. Calycera spinoli is moving quite dramatically. We've seen the same with Calycera aurata. And I would have said that several others, some of the Cryorhina, for example, are much more abundant now than 40 years ago in some areas. Now, whether that's a climate change impact or whether that's an ancillary factor that we've seen 20, 30, 40 years of tree planting, and those trees are now reaching a level of maturity suitable for saproxylics, I can't answer. I can certainly say in my local patch, when I started recording in the 1980s, Cryorhina did not occur there. Today, Cryorhina are quite widespread, as are Brachiopa, which I didn't see in the 1980s. So they are definitely, they're definitely there, and they've definitely come in. Now, whether that's climate change or whether that's the fact that we've got more habitat, I can't answer. What I would say, though, if you were looking at saproxylic conservation, the first thing I'd start to do is to have a moratorium on felling moribund street trees. Maybe do something more about making them safe, but the numbers of times you see wonderful pollarded trees, they've been pollarded for 40 years, they've got lots of lovely holes in them, and then they get cut down. Just as they're becoming ecologically interesting. I think we need a lot more emphasis on that. And I'm afraid I think, you know, this is an engagement with ARB officers who understandably are concerned about public safety, but have no concept of the impact they're having. So I would, for a start, ban stump grinders. I think they should all be taken to the tip and blown up.
Okay, some comments here. I think this is from Barbara Ismay, saying there was a very interesting talk at the last Congress from Alex, surname is Szydyank.
Axel Simank.
That's it. And he revisited a site in Germany and showed an 82% decline, much of this hoverflies.
Yeah, that's the Krefeld entomological group's work that was published by Caspar Hallman and company in 2017. Yeah, it's quite profound data. The only thing I might say about that is I'm not convinced that the extrapolations made are necessarily as robust as people are jumping to the conclusion over. After all, these are 1 or 2 malaise traps run at different sites on different years. So although there is something to go on, and there is certainly some very worrying evidence, I think I'd want a much, much bigger data set in terms of the numbers of traps run and the consistency of those traps run in a range of habitats, because I suspect we may actually be seeing different factors in different places. Bear in mind that we're talking about potentially picking up aerial plankton rather than very discrete habitat. This may be quite a lot about insect movement.
Okay, so interesting comment from Sue Taylor, talking about her local nature reserve, which she says is overrun with pheasants. And I understand the game bird densities are increasing, and biomass of pheasants is already greater than the combined biomass of native birds. I wonder if this is an issue in the southern woodlands alongside those already mentioned?
I can't really answer that. There are relatively few data sets that we can draw on to make any comment. The one thing I can say is that if we're going to start to make comments, firstly, we need better data sets. Secondly, we need some very, very targeted research to try and understand some of the relationships and some of the drivers. Now, that sort of research is just not happening. Now, I'm hoping that some of the things that BTO and I are talking about may actually end up with starting to drive some research. But at the moment, it's about turning a juggernaut. I've been trying to get a meeting together where we draw together some of the field specialists with the academics. And whilst the group that I'm talking to are very receptive to that, I don't get the same feeling of that receptivity from other parts of the academic world.
Okay. Right. So you're getting applause from Jenny Wilding for your comments on front gardens. And somebody else as well. Rob Davis is applauding you also for your front garden comments. And Elaine Wright, are we rearranging the deck chairs on the Titanic with practical conservation work, or can any actions make a difference against the overwhelming effects of climate change?
Well, the real question is, are you an optimist or a pessimist? My middle name is Eeyore, and as such, I might argue that no, there's not much chance of doing anything, and we're just going down the pan. Well, that's no good, because we've got to present some positive thoughts. We've got to try and drive the agenda. The reality is that, yeah, things might be pretty hairy, but unless we give young people something to drive for, they're going to give up, and that's no good.
Yeah.
You know, I'm quite prepared to be the last man standing at the battlements firing my machine gun. But the reality is, you know, you've got to mobilize the troops in a way that's constructive. And I think that's where I think we can do something with Dipterists Forum. We can say, where are the things that we can make a difference? Well, the most important thing is we can be much, much more assiduous in our recording. We can try to develop research programs together with some of the leading organizations such as BTO. We really have to start pushing that agenda and start to show the real depth and strength of organizations such as ours. We're the only ones, arguably, that have any taxonomic knowledge, and we're the only ones now with a great deal of ecological knowledge of invertebrates, not just Dipterists Forum, but, you know, BNHS and so on. It's field naturalists that have got the grip.
Yeah, I think I would agree with all of that, Roger. And I think, Elaine, yes, Roger makes an excellent point. We've got to be careful how we frame what we say about climate change, because it is, I think, to an extent, we, the scientific community, have got our psychology a bit wrong, and we've left everyone feeling, you know, hopeless and helpless. It's the Edvard Munch painting, you know, and you know that stops people from doing anything because they feel so hopeless and helpless about it that you just push it to the back of your mind. And I don't want to think about that; it's too depressing. And we need to frame it in a different way and say, here are some positive actions that you can take. Here are some things that you can do. Yes, we may well be moving the deck chairs, but if we don't put a more positive frame around it, then people will just carry on not doing anything. I think the hopeless and helpless feeling is having a big sort of drag effect and stopping from people doing the little things. So, you know, let's just identify things that will be constructive and highlight them and say, here are some constructive things you can do. Off you go, do these now. This is a good thing to do, because the alternative is to do nothing. And let's not think about that. Okay, we've totally run out of time, Roger.
That's all right.
I need to scurry away and get myself a drink, and we've only got 3 minutes before it's time for Will's talk, so I'm going to have to stop there. There are some more comments in the chat, so I can pick those out, and if there are specific questions to Roger, I will email them to Roger and get a response from him for you. So